Okay. Hello, everyone, and welcome back. Let's get the backup recording just in case. Screen, entire screen, share. All right.
Recording in progress.
Hello, everyone, and welcome back. We are continuing on with the MCT4C course. This is the Math for College Technologies, grade 12 college. And we are on Unit 4, Lesson 17, Part 2 of 2. And we're continuing on with imperial and metric measurements, conversions, as well as some specific applications. And so for today, we're going to be converting measurements to and from metric and imperial systems, and we're going to be looking at applications of metric and the imperial system. So we will know things have gone well if we're able to create a conversion table to help me create ratios to solve for converting units, and you're able to solve applications involving metric and imperial measurements. Okay, so as a review, there's two key components to make these work. One is to be able to solve these kinds of calculations. So here, for the review portion, we are looking to solve for the missing value in each of the following. So for letter A here, we have x divided by 10 is equal to 1 over 2.2. So we want to use that means and extremes. So we're going to multiply this 2 times x, and that'll be equal to 10 times 1, which is just 10, but we'll just leave it like this. Divide both sides by 2.2. And so x will be equal to 10 multiplied by 1 divided by 2.2. And so typing that into the calculator here, and today I just have the Desmos scientific calculator. So 10 times 1 divided by 2.2 is this 4.54 number. And so you can make it a fraction, but it is customary to write these out in terms of their decimal. So we're going to assume 2 decimal places. Normally the question will tell you, if they don't, usually 2 decimal places is enough. So we're going to say that this is equal to rounding, of course. Okay, let's try letter B. We have 1 over x is equal to 1.609 over 40. So we're going to use the means and the extremes. And we're going to have 1 multiplied by 40 is equal to 1.609 multiplied by x. Divide both sides by 1.0609. And we get x is equal to 1 multiplied by 40 divided by 1.609. And so on your calculator, you can go ahead and type that in. And again, I'm just using the Desmos scientific calculator today. And we get a solution here of about 24.86, some sort of units. Okay, so we solved for an x in the top left numerator. We solved for an x in the bottom left denominator. Let's solve for an x in the top right numerator. And so in this case here, letter C, we have 25.2 divided by 3 is equal to x over 15. So again, we'll use the method of means and the extremes to solve this. So it'll be 25.2 multiplied by 15 is equal to 3x. Divide both sides by 3, and we get x is equal to 25.2 multiplied by 15 divided by 3. So on our calculator, you can just type this in. 25.2 multiplied by 15 and dividing this by 3 yields as an answer that x will be equal to exactly 126. Lastly but not leastly, we have 3 divided by x is equal to 7 over 6. So again, the means and the extremes. We're going to take 3 multiplied by 6, and that'll be equal to 7 multiplied by x. We divide both sides by 7, and we end up with x is equal to 3 times 6 over 7. And on our calculator, we can take 3 multiplied by 6 divided by 7, we get this 2.57 number. After rounding, of course. So I write it on the same line where I say it's equal to exactly this number, but it's approximately this. But if you so wish, you can just continue writing this vertically. Either's okay with us. So that's like a nice little review of what we had to look at so far. Okay, so we're continuing on now. So we're going to be using the same chart that we had from the lesson of last time, where we were, and this was directly from the textbook, where we were considering conversions in the metric system, considering conversions in the imperial system. But primarily for today, we're going to be focused on conversions between the two systems. Namely, we know 1 inch is equal to 25.5 millimeters. 1 foot is equal to 30.48 centimeters. 1 yard is 0.9144 meters. And 1 mile is equal to 1.609 kilometers. And for measure, I also included a common one. There are 0.2-ish pounds in a kilogram. So we're going to use this as well. Okay. So for example, one, we're going to convert between the imperial metric systems. So I want to convert 300 millimeters to inches. And so I know that 1 inch is equal to 25.5 millimeters. And I want to know how many inches there are in 300 millimeters. So this will be the setup. So again, you want to make sure that the top row is filled in for inches. The bottom row then is filled in for millimeters. The order of this doesn't matter because as we saw from earlier, we can solve for x wherever it needs to be. And we can set up a ratio that we're interested in. So this will be 1 over 25.5 is equal to x over 300. Using the means and the extremes, we have 1 multiplied by 300 is equal to 25.5x, which means x will be equal to 1 multiplied by 300 divided by 25.5. So on our calculator, we can type that in, 1 multiplied by 300. Oh, 1 multiplied by 300 divided by 25.5, we get 11.76 after rounding, of course. And so again, question doesn't stipulate, so we'll just assume 2 decimal places is likely more than enough. Okay. What about 180 pounds to kilograms? Well, we have to use that new conversion I gave us. So we know that there are 2.2 pounds. Let's use the symbol for pounds, LB, in 1 kilogram. And we need to know how many kilograms there are in 180 pounds. So important, make sure to list. So in this chart, ensure to list your units. And you'll find things tend to go much easier. Because it takes a lot of the guesswork as to what you're supposed to do, because as long as you know that one row has to contain the same kind of unit, then you know things are going well. Okay, so we can set up a calculation for this now. So we're going to have 2.2 over top of 1 is going to be equal to this 180 over x. Using the means and the extremes, we found that 2.2x is equal to 1 multiplied by 180. So x will be equal to 1 multiplied by 180 divided by 2.2. And so on our calculator here, we take 1 multiplied by 180 divided by 2.2. And that's going to be 81.82, and these are kilograms that we're looking for. So this ended up being 81.82 kilograms. So again, the key thing to make this work is identify the measurement that you need, set up the chart as you need it. In the notes here, I just included a lot of the charts that we're probably going to need for each question just to cut down on time. But I post all of my notes online, so you do have access to these. Okay. What about letter C here? We have 45 miles to kilometers. Well, they told us that 1 mile is 1.609 kilometers. So here, 1 mile is 1.609 kilometers. And we want to know how many kilometers there are in 45 miles. Okay, so we know that we did this right because the top row is miles, the bottom row is kilometers. So we can set up our ratio. So 1 over 1.609 is equal to 45 over top of x using the means and the extremes. We have 1 times x, which is going to be x, is equal to 1.609 multiplied by 45. So this is going to be like 67, 68, something like that. So we take 1.609 multiplied by 45. Oh, it's actually much bigger. So x is going to be 72.41 kilometers. Okay. So in general, a mile is longer than a kilometer, so this answer does make sense. Okay, well, let us continue on. Last but not leastly, 35 kilometers to miles. So just like before, we could mimic the steps that we used last time. We know that 1 mile is be 160, and we want in 35 kilometers. Okay, so we can set up our corresponding ratio. So 1 over 1.609 is equal to x over top of 35. Using the means and the extremes, we find that 1 times 35 is equal to 1.609x, and dividing both sides by 1.609 yields x being equal to 1 multiplied by 35 divided by 1.609, which is going to be some number under 35. So 1 multiplied by 35 divided by 1.609. So we get x is equal to about 21.75 miles. And the symbol for miles is mi. If you so wish, you could just write out the full word. There's not wrong with writing out mile. Just may indicate some sort of unit for these, since we are in the land of converting units. Correct and write the unit you want to be ending up in. So from above here, I should have put inches. Okay, so let's continue onwards. Now, specifically, it's a little bit of a weird situation insofar as lesson 17 has some questions that ask you about perimeter, and then wants you to find it in different units. We don't really study perimeter at all, just like very briefly here, because the next unit we actually study is area and surface areas. So we're going to be spending the next 2 days on that. And so just as a quick little reminder, if we want to find the perimeter of different is defined to be the distance around the outside of an object. Okay, or shape, or have you. So perhaps we'll say a shape. Okay, so we're going to determine the perimeter of the following in metric and imperial. So for here, they just give us either like some of these things are in centimeters, one of these shapes is in inches, and another one is going to be in yards. So we're just going to use the equivalent comparison that they gave us in this chart to know what to convert it to. So for example, this one's going out of the way to mention this in centimeters. So we're just going to convert this over into feet. Okay. So know that 1 foot is equal to 30.48 centimeters. And that's the conversion we're going to use. Okay, so we want to find the perimeter of this thing. So typically is we let capital P represent the perimeter. And we're going to be using that for all of these. So we're going to just write this out once. So in this case, we just add up the distances around the outside. So capital P will be equal to 0 plus 3.6. There is no difference between mathematically 3.0 and 3. The reason why you would have measurements rounded off like this is if you approach this from a scientific perspective where you wanted to preserve how many decimals you were trying to round each of these answers to. So in this case, we're saying that it's 3.0 because we want to have 1 decimal point of precision. But again, that's a topic for another day. Okay, so to add these all up, we'll use a calculator. So 1.2 plus 3 plus 3.6. And our perimeter here is going to be 7.8 centimeters. So that covers the metric portion. So the imperial portion, we now have to do this conversion. So we know that 1 foot is 30.48 centimeters. That means we will have how many feet 7.8 centimeters is going to be. So setting up our ratio, we have 1 over 30.48 x over 7.8. Okay, using the means and the extremes, we find that maybe we'll use the same color for this. 7.8 is equal to 30.48 multiplied by x. And so isolating for our x term, by dividing both sides by 30.48, x will be equal to 1 multiplied by 7.8 divided by 30.48. So on our calculator, we can type this in. 1 multiplied by 7.8, and we're dividing this by 30.48. And we get x is equal to 0.26 feet. Okay, so for these questions, you don't have to worry about trying to convert to the best measurement. The textbook just wants this listed in metric and imperial. So use whatever the easiest conversion is. If you really wanted to, you could have converted these centimeters over into millimeters and then converted from millimeters to inches. But again, it doesn't specify feet or inches. You just choose any imperial measurement that's reasonable, and then you're okay. I say reasonable because, try not to convert to kilometers when you're working, or sorry, try not to convert to miles when you're working in centimeters and so forth. Just use what's there. Okay, next one here is in inches. So we can see that for an inch is 25.5 millimeters. So we know 1 inch is 25.5 millimeters. Okay, what do we have here? So this is what we call a trapezoid. Okay, so it's got 2 parallel lines, top and bottom, and then it's got these 2 slants. So importantly, it's also got these fractions in here. And your question to me is very reasonable. Do we have to stick with fractions? Absolutely not. So we're going to convert these 2 fraction numbers into decimals. So if I take 1 divided by 5, that's going to give me 0.2. So this 5 1/5 of an inch becomes 5.2 inches. The 7 3/5 of an inch becomes 3 divided by 5 is 7.6 inches. So this trapezoid has lengths around the outside of 5.2, 4, 7.6, and 13 respectively. And so we can calculate its perimeter. So capital P will be equal to the sum of the corresponding distances. So this will be 5.2 plus 4 plus 7.6 plus 13. So P for perimeter will be equal to the sum of these numbers. And so you just type these into your calculator. Again, I'm just using the Desmos calculator. That's more than plenty for this lesson. And we end up with 29.8 inches. And so now we need to convert. So we were given this as an imperial measurement. So we need a metric measurement now. So luckily we have the millimeters will suffice. So we know that 1 inch is 25.5 millimeters. So we need to know how many millimeters is 29.9 inches. And the answer is a lot more. So let's have a look. So setting up our ratio, we have 1 over 25.5 is equal to 29.8 divided by x, using the means in the extremes, gives us 1 multiplied by x is equal to 25.5 multiplied by 29.8. And 1 times x is just x. So x will be equal to 25.5 multiplied by 29.8, which is going to give us 759.9 millimeters. And this is going to be our metric answer. Okay. Lastly, but not leastly, suppose we have a rectangle with side lengths of 14 yards and 10 yards. So this is talking about yards. The relevant measurement here is that 1 yard is equal to 0.9144 meters. So 1 yard is equal to 0.9144 meters. And usually for this, it's usually a good idea to sketch the shape, because you never know. And if I had to list out steps for this question, sketch the shape, find the perimeter, use a conversion chart, and solve the ratio. Okay. A lot of these steps tend to be the same, but again, we're going through plenty of practice because typically we found in the past that if students were having troubles with ratios in the past, it helps to spend lots of extra time on it to make sure things go well. Okay, so step 1, we're going to sketch the shape. Okay, fair enough. This is good practice because sometimes we have to sketch more complicated shapes. So we start with the basic ones and work our way up. So one of these sides is 10 yards. The other one is 14 yards. Now, due to what we know about rectangles, we know that the opposite sides will be the same. So this side will also be 14 yards, and this other side will be 10 yards. So the second point we need to do is determine the perimeter. So the perimeter will be the sum of these 4 sides, namely 14 plus 10 plus 14 plus 10. So this will be 20 plus 28. So the perimeter is going to be 48 yards in length. And again, this is going to be the imperial measurement that we were interested in. So knowing that this rectangle has perimeter of 48 yards, we can use our conversion chart because we're curious to know how many meters there are in 48 yards. So our ratio has been set up. And so to solve the ratio, we're interested in trying to determine 1 divided by 0.9144 is equal to 48 over x. Using the means and the extremes, we take 1, multiply it by x, and that'll be equal to 0.9144 multiplied by 48. 1 times x is just x. And so if we were to take 0.9144 multiplied by 48, we get this 43.8912 meters, but we already said just 2 decimal places is more than plenty. Okay. And because again, we don't need that much precision. So if we had every single decimal place, this would be like finding something below a millimeter with respect to accuracy. So like 0.2 of a millimeter, we don't need to worry about that. Let's continue on. Okay, so now we're going to look at some applications, and in a nice little twist, we can actually use this no need chart to set up a ratio to solve these kind of questions. So again, for continuity purposes, I listed off the same chart that we had from earlier. This will come up in subsequent questions, but we're going to see how we can apply this chart. So example 3 deals with applications of imperial and metric conversions. So for letter A here, suppose a plane travels at 900 kilometers an hour. So that's about the cruising speed between Thunder Bay and Toronto. How long will it take for the plane to travel 6,000 kilometers? And so what do we know in this case? Well, we know that a plane will travel 900 kilometers in 1 hour. So this 900 km/h means 900 kilometers in 1 hour. So if we can travel 900 kilometers in 1 hour, how many hours will it take to travel 6,000? Presumably more than one. So we can set up our corresponding rate. 900 divided by 1 is equal to 6,000 divided by x. So using the means and the extremes, we end up with 900 multiplied by x is equal to 1 divided by 6,000. And so x will be equal to 1 multiplied by 6,000 divided by 900. I think it's going to be like 5.4 repeating. So 1 multiplied by 6,000 divided by 900. Oh, off bit. So this is going to be 6.66 repeating. So we'll call this 6.67 hours. So since this is an application question, we will say, therefore, it will take 6.67 hours for the plane to travel 6,000 kilometers at 900 kilometers an hour. It's important to make sure you list off these little sentences just to make sure that we're answering the question they wanted. Now, in this case, this question happens to be like a one-step kind of question where we only needed to do one calculation in order to solve this. Sometimes we need to do multiple calculations, and if that's the case, we want to make sure our steps are clearly defined. And so an example of that is going to be in this question. Same kind of setup. So we're going to be traveling the United Kingdom and need to travel a distance of 300 miles. If your vehicle can travel at 95 kilometers an hour, how long will it take to travel the distance? And so we will need to convert the miles to kilometers or the kilometers to mile, and then go ahead and solve. So this is going to be 2 ratio calculations. So we'll write that down. So this is 2 ratio calculations. And we want to convert the miles to kilometers or vice versa. Okay. So first thing, we should recall that a mile is 1.609 kilometers. So we know that 1 mile is 1.609 kilometers. And we're interested to know how many kilometers are in 300 miles. So there's our ratio. And so this is going to be 1 over 1.609 is equal to 300 over x. Using the means and the extremes, we have 1 multiplied by x is equal to 300 times 1.609. So 1 times x is just x. So if we take 300 multiplied by 1.609, we get how many kilometers that's going to be. And so you can see in this case, this is going to be 482.7 kilometers. So luckily now, we can now just apply our second chart immediately because we know that the car travels at kilometers in 1 hour, and we're curious how long it'll take to travel 482.7 kilometers in however many hours. This case looks like it's going to be about 5. So setting up our ratio, we can say that 95 over 1 is equal to 482.7 over x. Using the means and the extremes, we can say that 1 multiplied by 482.7 is equal to 95x. Dividing both sides by 95, we get x is equal to 1 multiplied by 487.7 divided by 95. And so let's run through this calculation. 1 multiplied by 487.7 divided by 95. And we get that this is, again, about 5 hours. So we'll say 5.13 hours. And from here, I don't have any more space, but just make sure you get your therefore statement in. Okay. Let's continue on. Okay. So which is longer, 1,000 meters or 1,000 yards? Okay. Easy question. 1,000 meters, because we know that a yard is smaller than a meter. Oh, it says prove your answer. Okay, fair enough. So this question would be worth 2 marks. 1 mark for stating which one is longer, a second for proving your answer. So how do you prove your answer? So we know the 1,000 meters is going to be larger. It's not always the case, but in this case, it's very clear because it's 1,000, but we could have been comparing 2 stranger numbers instead. So to prove your answer, in this case, we want to ensure we are working with the same units. So we're going to convert the yards to meters. Okay, so we know that 1 yard is equal to 0.914 meters. So 1 yard is equal to 0.9144 meters. And we're curious to know how many meters is 1,000 yards. Since we have to convert one to the other, it doesn't matter whether we wanted to convert the 1,000 meters to 1,000 yards or the 1,000 yards to 1,000 meters. We just want to be very clear about which one we're doing. So let's convert the 1,000 yards to meters. And so the ratio we're interested in solving will be 1 divided by 0.9144 is equal to 1,000 divided by x, using the means and the extremes. 1 multiplied by x is equal to 1,000 multiplied by 0.9144. And so x will be equal to, in this case, 19.4 meters. So, and if you're not sure about that, again, you can just use your calculator to confirm that this is the case. And there it is. So we have a therefore statement. So therefore, 1,000 meters is longer since 1,000 yards 1,000 yards is only equal to 914.4 meters. Okay, so this is a case where it makes a lot of sense to write a therefore statement, because when you're trying to show or prove things, you want to be very clear about how you're going to be ending up with this. So in our case, as part of the proof, we wanted to ensure we're working with the same units, and we were going to convert just the yards to meters so that we had the same units. So there was very little misunderstanding about which could be which. Okay, let's continue on. So a very obscure section of the textbook deals with converting areas. Typically, we don't do this, and so when we talk about convert, we don't usually do this. And so instead of talking about lengths, like the distance around the outside of a shape, we're going to be talking about areas, the space something fills up. So I have a diagram that helps us going to describe what to do here. Okay, so we're going to consider a 1 square foot. So to do that, that's pretty straightforward. We have a square, and we make the claim that each side is 1 foot. So then the area will be equal to 1 times 1, which is 1 square foot. Okay. Now here's where the kind of the trick happens and where it gets a little bit unusual. So we know that 1 foot is equal to 12 inches, right? And that's what this diagram on the right here is trying to show. So here I started off with my square foot, and now I claim that since 1 foot is identical to 12 inches, I can rewrite this 1 foot times 1 foot being the exact same as 12 inches times 12 inches. And if I want to find the area of this, the area is still done the same way. We say area is equal to length times width. So the area for this is going to be not 1 times 1, but actually 12 times 12. So the area is going to be 144 inches squared. Now we should use the notation for this. Normally I type this up. So these are square feet and these are square inches. So we end up with an unusual situation where we have now claimed that one square foot is equal to 144 square inches. And indeed, that is the case. So when it comes to converting areas, you actually need to, you can't just take the square feet and divide it by, say, 12, end up dividing by 12 or multiply by 12. You actually have to do that twice. And we're going to see what that looks like when we talk about feet. So if I want to convert 3 square feet to square inches using this notation, I know that 1 square foot is equal to 144 square inches. And we're curious to know how many feet is how many inches is 3 square feet. So setting up our ratio, we have 1 over 144 is equal to 3 over top of x. Using the means and the extremes, we find that 1 times x is equal to 3 times 144, which is going to be equal to 432 square inches, or inches squared. If you're typing this out, it's perfectly okay, just because I'm actually very used to writing it this way. It's okay to write this as like 3, and then you can write square as an SQ and then feet, or you can use the little 2. Okay. Now, what about cubic inches? It actually runs the exact same way. So instead of where we know that if we take a 1 foot is equal to 12 inches, and we know that 1 foot square is equal to 12 times 12, which is 144 square inches. When you want to do cubic feet, that's talking like the volume of a room. The calculation for that, well, your intuition might be telling you, do we just multiply by another 12? You sure do. And so in that case, 1 cubic foot is equal to 12 times 12 times 12, which is going to be 1,728 cubic inches. And that's the calculation. So if you have a cube of something, that's equal to 1,128 cubic inches. And this conversion works for all of the different areas that we can convert. So if we have to worry about converting like square miles to square kilometers, we would end up using this similar calculation to what we did here, where we essentially just say we keep multiplying by a factor of, like, say, 0.9144 and so forth. Okay, so what do we know? We know that 1 cubic foot is equal to 1,728 cubic inches. And we're curious to know how many cubic inches there are in 3 cubic feet, or 3 feet cubed. So we set up our ratio. 1 over top of 1,728 is equal to 3 over x. Using the means and the extremes, we find that 1x is equal to 3 multiplied by 1,728. 1 times x is just x. And so 3 multiplied by 1728 is going to be 5,184 inches cubed. So you get quite large numbers when you start converting volumes. It's quite a lot. Okay. And if you think about if that's like it seems like kind of a lot, right? I'm like, I would agree. But if you think about, if you try to lift like a cubic foot of anything, like that's a lot of space that you're now talking about, right? Like a cubic foot of water it's like the size of a cooler, right? Like that's, if that was all water, it's actually quite a bit more than you think it is, right? And if you're trying to line it with some sort of smaller cubic inches, you actually fit quite a bit in there. Okay, let us continue on. And so we have this conversion here. So example 4, we have imperial and metric conversions involving area. So we're going to solve the following. And we have 2 examples, and that's going to close this out for the day. So example A says, suppose an area of land is 20 kilometers squared. How many square miles would that be? Typically a pretty difficult example to think about, but luckily we can just invoke this technique that we learned earlier to help us. And so consequently, we know that 1 mile is equal to 1.609 kilometers. So 1 mile squared is going to be equal to 1.609 times 1.609. So on my calculator here, if I take 1.609 and multiply by 1.069, mixed it up, 609, I get 2.588 2.588 around this, the 2 kilometers. So if you're talking mile, the same as about 2.5 square kilometers. And so now we have our conversion. And so we know that 1 square mile is equal to about 2.59 square kilometers. And so what we're then curious about is how many miles are there, square miles are there in 20 square kilometers. And it's going to be less than 20, right? So we could see that it's probably going to be about maybe 10 or so. Well, actually, it's going to be under 10. So solving using our ratio now, we're going to have 1 over 2.59 is equal to x over 20 using the means and the extremes. We're going to solve 1 multiplied by 20 is equal to 2.59 multiplied by x. And dividing both sides by 2.59, we have x will be equal to 1 multiplied by 20 divided by 2.59. So later here, multiplied by 20 divided by 2.59. So this is going to be about 7.72 square miles. And so we would say, therefore, is it 20, right? 20 square kilometers is equal to 7.72 square miles. So you can get, like I said, the conversions on the area go quite wild when you start trying to get these things. Oh, excuse me. Okay, last example. And again, we have the same chart from before. We have a question. Suppose a can of paint can cover 30 square meters. If a room has an area of 630 square feet, how many cans of paint are needed? So we have lots of steps to this question. So I've included a few of these no need charts. So the first thing we want to do is to be able to convert from square meters to square feet or square feet to square meters, either or. So let's have a look here. Well, we can see that 1 foot is equal to about 30.4 centimeters. And once we're in centimeters, we can see that there are 100 centimeters in 1 meter. So those are going to be the conversions we're going to be using. Okay, so in this case, we ended up having to use a combination of a couple of different ones. And so let's move the square feet over into square meters. Okay, so we know that 1 foot, so let's call this part here, we're going to convert areas. So we know that 1 foot is equal to 30.48 centimeters. So 1 square foot is going to be equal to 30.48 multiplied by 30.48. So my calculator right here, if I take 30.48 multiplied by 30.48, that's going to give me 929.03. And these are in centimeters squared. Okay, so what if we were in centimeters squared now? Well, we want to convert from centimeters to meters then, right? So we know that 1 meter is equal to 100 centimeters. And so 1 meter square will be equal to 100 times 100, which is 10,000 centimeters squared. So those are going to be the ratios we're going to use. So for the first one here, we're trying to convert 630 square feet over to centimeters. And so we know that 1 square foot is equal to 929.03 square centimeters. And we need to know how many centimeters would be 630 square feet? And so using our calculation, we have 1 over 929 will be equal to 630 over x. So that means 1 multiplied by x will be equal to 929.03 multiplied by 630. So x will be equal to, this is some large number, so 929.03 multiplied by 630. So this is 585,288.9 centimeters squared. And so now we can use the next ratio. So we know that 1 square meter is 10,000 square centimeters. And so we're curious as to how many square meters there are in 585,288.9. And so we set up our ratio. 1 over 10,000 is equal to x over 585,288.9. We multiplied by this. So we're going to have, here we go, need the space. So we're going to take 1 multiplied by 585,288.9 is equal to 10,000 multiplied by x. So x will be equal to, I'm going to say 1 times 585,000 is just 585,288.9 divided by 10,000. And so we're going to take the 585,288.9, 585,288.9 divided by 10,000. And so we're going to see that this is equal to 58.53, and we are in square meters. Okay, so let's kind of recap where we ended up. So we know a can of paint covers 30 square meters, and we found a room that has an area of 630 square feet. So if you have a room that's a 630 square feet, we found that the equivalent rate, we found that that was equal to 58.53 square meters. What we had to do first was we had to figure out our conversion ratios. So 1 square foot was 929.03 centimeters. 1 square meter was equal to 10,000. Performing the following, we ended up with the room being 58.53 meters. Okay, so now we need to paint the room. So what do we do here? Well, we know that 1 can of paint, suppose I'll work in black for this one. We know 1 can will cover, and we said 630 is now going to be 58.53. Oh, sorry. We said that 1 can was equal to 30 meters squared, and we need to find out how many cans we need to fill a room that is 58.53 meters squared. So setting up our ratio, 1 over 30 is equal to x over 58.53. So we end up with 30x is equal to 58.53. So x will be equal to 58.53 divided by 30, and that's going to be 2. So if we take 58.53 divided by 30, we end up getting 1.951, but you can't go buy part of a can of paint at the store. You have to go buy a full can of paint. Therefore, you're going to need 2 cans. Okay. So with this was our lesson on converting areas between metric and imperial, as well as 2-dimensional areas. And we did an example of a 3-dimensional area. This should take you through and you should be able to complete the rest of lesson 17. Tomorrow, we're going to begin looking at areas where we'll be studying the area of simple and composite 2-dimensional shapes. So as always, if you have any questions, please feel free to reach out. But please have yourselves a wonderful night, and we'll see you all soon. Goodbye for now.